Good morning, everyone. Thank you for coming. So, today is our last class, so I will a little bit rush in the progress. Uh, so, I will not wait for you for the practice, so you need to practice on your own. Okay. So, okay. So, what we will discuss today, there are several things I want to discuss with you. Number one is association. Okay. So, association. So, part of data mining, artificial intelligence is uh, association. Okay, so one part is this called supervised learning. In supervised learning, you have learned about LDA, right? Decision tree, and then what else did you learn? Neural network, right? Now, association, okay, is another technique. Okay, which is used for especially for business right here. Okay, so you have seen this in application. For example, in Amazon, okay, if you buy a certain book, okay, if you search certain book, okay, it will say browse related titles. Okay, in Netflix, when you watch certain movie, right, it will also suggest another movies for you, correct? So this is the application of association. So customer who bought this item will also bought other items. Okay, so these are other examples. So people who buy bread and cheese may also buy, for example, butter, right? Jam, milk, and honey. So people who buy cold medicine frequently also buy tissue and orange juice. Okay, so people who buy Barbie dolls will also buy one of the three type of candy bars, for example. Okay, so how we will know about this? What people purchase, the purchasing behavior, right? So customer who buy a certain maintenance agreement, okay, they also usually buy large appliance. Okay? So people who buy a certain hardware store will also buy, for example, toilet bowl cleaner. These are example of application. So using this technique called association, okay, we are able to identify who are the customer, why customer buys certain products, and then you can also promote, right? So a product that may benefit from the promotion. And then based on this, you can also do what is called cross-selling. That means certain products are purchased together. And you can also do what is called product placement, meaning in the store, which item should be put together. Okay. So the way you put items together is to maximize your business. Okay. Now, combining all of this with a loyalty card, for example, then it will become more valuable, isn't it? Now, in Indonesia, most of the loyalty card you still need to pay. Okay? But in other countries, usually you will get, actually you're supposed to get the payment because you get a loyalty card, mean they will get your data. Based on your data, okay, they can track your purchase, right? Based on the purchasing that they track, then they can promote something to you, then they can sell more. So is it important for you? Association, right? So one of these application method is called market basket analysis, or called MBA, right? So what is this? This is the tool for knowledge discovery about co-occurrence, okay, of nominal or categorical items. So here your data are all nominal type, okay? Not ordinal, not numerical, all categorical, only nominal type. In fact, they are the name of the items. Okay? For example, if they are books, so the name, the title of the books. Okay? If this is in the grocery, so the name of the brands of the items. Okay, so MBA or market basket analysis is a data mining technique or machine learning technique to derive association between two data sets. Okay? The input are categorical data. Okay? The output are association rules. So similar to other data mining or machine learning technique, okay, the output are the rules. The input are the data. But be careful in here, the data are always categorical or nominal data type. Okay? So, what is association rule? Association rule is in the form of if X, then Y. So, X in here is left-hand side. I call this antecedents. The right-hand side is called consequence. Okay? So, for example, X represent bread and cheese. Okay? The Y is bread, butter, jam, milk, and honey. So these are the items. Okay, so that means people who bought bread and cheese will also buy butter, jam, milk, and honey. Okay, so these are other examples. So what happened? If you have co-occurrence matrix, meaning that these are the purchase item for each customer. So suppose we have these 5 customers. Okay? So each row in here represent the transaction, okay, of one customer. And then we can create a co-occurrence matrix here. So co-occurrence matrix means how many items was purchased for all customers. So 4 here meaning that orange juice is purchased 4 times alone. Orange juice alone. Okay. Orange juice and window cleaner was purchased 1 time together. Okay, and so on. Okay. Now, using this matrix alone, you can already say that orange juice and soda, for example, here, 2, right? Orange juice and soda are more likely purchased together than any other 2 items because any other 2 items are having co-occurrence of 1 or 0. So detergent never purchased with milk and window cleaner. The occurrence to happen together is 0. Milk never purchased together with soda or detergent. Okay. So now, how to create the rules? How to create the association rules? So to create the association rule, you need to define at least 2 things. Okay? There are many other measures, but these are the most common and most important one. It's called support and confidence. Okay. So suppose the support of 5%, okay, the support of 5% show that 5% of all transactions indicate that item on the set X, okay, the antecedents, and Y are purchased together. So support represent the intersection between X and Y. Confidence. When we say confidence 80%, show that 80% of the customer who bought item on set X also bought item on set Y. What's the difference? Confidence and support. Okay. So here it is. Support represents the frequency of transaction to have all the items on both set X and Y are bought together, bought together. So this is represent the probability of the intersection between the 2 sets, X and Y. Okay, so this is the probability of the intersection. So Nx intersect Y divided by N. N here the total number of transactions. Okay, so this is the total frequency of the set intersection divided by the total number of transactions in the analysis, right? So a rule, you can find the rule that very give very low support, okay, that means they are occurrent only happen by chance, lucky only at that point. Okay, so you need to have a very strong support to create the rule. Second measure is called confidence. What is this confidence? This is called conditional probability. Conditional probability of what? Conditional probability to obtain the set Y given the set X. So we know, okay, the definition of conditional probability of Y given X is what? The number of the set X intersect Y divided by the number of X. Okay, so this represents the total frequency of the set intersection divided by the total frequency of set X. So what is this? This measures the accuracy or reliability, okay, of the inference. Okay, so again, come back to this example. How good is the association rule? Okay, what is the confidence of this rule? If a customer purchases soda, then the customer also purchase orange juice. So then you calculate, okay, when the orange juice and soda are purchased together. So you can see, okay, that 2 out of 3 soda purchase is also include orange juice. So the confidence is 67%, yeah, 2/3. How about the confidence of the rule reverse? Okay. So that means 2 out of 4 orange juice purchase also include soda. So the confidence become only 50%. So be careful, yeah? If confidence is one way, support it's two way. Okay, is symmetric. Okay, this is another example. Okay, so suppose these are the transaction ID and these are the item box bought by each transaction. Okay, so A, B, D, and so on. These are the name of the items. Okay, and to find all the rule X imply Y, okay, with the minimum support and confidence. So to do that, you get the, what is that? The intersection between X and Y. Okay, and then you set the threshold for the support and the confidence. From there, you can create what is called association rule. Okay, for example, the association rule that A will be purchased together with D, okay, will give certain support like 60% and confidence of 100%. So you set the threshold of the support and the confidence, and then you cut off based on the threshold. So these are the other examples. So can you calculate the support here? So these are the items are beer, bread, jelly, milk, and peanut butter. And the support for bread and peanut butter is how much? 60%. Why? Okay. Because you have 5 transactions and then you check, okay, bread and peanut butter together is 3 out of 5. That means 60%. Okay. Now, based on that, you can calculate the support and confidence for each item, each combination of the items, right? Support and confidence for each combination of the items. Then you can create the rules. Okay? Each combination of the items create the rules. Okay, so these are the example. Oh, if they buy bread, then they will buy peanut butter. How do you know this rule is correct or not? Well, you just calculate the support and the confidence. Okay? If the support is higher than certain threshold and the confidence is also higher than certain threshold, then that rule apply. If the support and confidence is low, then that rule does not apply. As simple as that. Okay, so I give you example. Okay, here is the example you can see in my website. Okay, I just give 7 transaction data here. So I just use item for the customer who bought more than one item. So this is apple, banana, cherry, durian. So I will put A, B, C, D, the name of the fruits here. Okay. So from there, you can see I can generate the rules, right? How do you generate the rules? Well, you just check all the combination. For example, A, B, A, C, A, D, because there are only 4 items, right? A, B, C, D, right? Then what? A to B and C, A to C and D, A to B and D, yeah? A to B, C, and D. And then again, from B to A, B to C, B to D, yeah, B to AC, B to C, D, and so on. Okay, so you generate all this combination of the rules. Is it clear? So from there, what you will do is, okay, so all the combination of the rules, okay, so of course, if you have only 2 items, there are only 2 rules. If you have 3 items, you have 12 rules, right? If you have 4 items, you have 50 rules. Okay. If you have n items or r items, okay, then these are the total number of A. If the total number of item is D, then the total possible association rule is R. So very big. If your item number is 500, so very big to generate the number of possibilities. Okay. So in that case, the algorithm, basically like a priori algorithm, which is already inside WK, or you can just check in Python, right? So what happened is this a priori algorithm is basically to prune all these possibilities of the rule. Okay. So the technique is rather simple. You generate all the combination of the rule, and then you compute the support and the confidence. So giving the support and the confidence, then you can create the rules that apply. Okay, so these are the technique to compute using Excel. So I just, if you want to follow, you can practice by yourself. You can actually calculate, okay, using Excel only without programming. Yeah? You can already do all of this. Yeah? So you calculate the support, you calculate the confidence, right? And then you apply the threshold criteria. Okay. Then based on that, you will see whether they are in the rule or not, right? Then these are the all association rule, because I have 4, in this example, I have 4 items only, right? So then I can check, okay, I do a filtering to check which rule, okay, will be the output of the association rule. So in this case, B, D, and C to D. Okay, so after that, you can experiment with the threshold to change the minimum support and minimum confidence. Okay, up to here. Any question for association? Can you follow? Am I too fast or what? Give me feedback.
For me, that one a bit too fast, sir.
Too fast.
A bit, just a
Okay.
bit.
So what did you get first, so that I will. What did you get?
Like the part where how you apply the association to buying the items, sir. That one. After that, it's kind of blurry.
Okay, the technique inside. Okay, so I will just put
Uh-huh.
inside. So, okay. The technique inside is to generate all the rules using combination. Okay, so here it is. I will give you the example in Excel so that you can just see it. Okay, So these are the transaction that I have. Seven transaction, right? And these are the item that bought for each transaction. Is it clear or not? Can you see it?
Yeah, I can see.
Okay. And then the parameter that I give in here is just simple. Minimum support, minimum confidence. Okay. So these are the input. The input are these items and then the two parameters that I set. Okay. These are the input. The output are the rules. What is the rule? The rule is telling that A will be purchased together with D. B will be purchased together with D. C will be purchased together with A. C will be purchased together with B and D. So how do I get this rule, isn't it? That's your question, right?
Yeah.
Yeah. So the computation, so I will just show you the computation now. Okay. First, I binarized all these transactions a while ago. Okay. For example, a while ago, what do I have? Apple, banana, cherry, durian, right? So I have 4 items, so I will put binarize, so 1, 1, 1, 1.
Mm-hmm.
Okay. So
Mm-hmm.
then I will know from this 7 transaction how many purchase for A, how many purchase for B, C, and D, right? And
Yeah.
then I generate all the rules here. Can you see? These are all the rules. 50 possible rule for 4 items, right? So these are the 50 possible rules. Can you see it? This is rule for A, this is rule for B, C, D, and then A, B, A, C, A, D, B, C, B, D, C, D, A, B, C, and so on. Okay? These are all possible rules. Up to here, clear or not? The all possible rules.
Mm-hmm.
Okay? After that, what I will do, I calculate the what do you call this? To calculate the support and confidence. How to calculate the support? You get the intersection between X and Y, right?
Yeah.
So A and B together, how many items happen here? A and B together. So these are A and B, right? This
Uh-huh.
is A and B, so 2 times. Okay. So this is the computation how many times that A and B purchase together. Intersection mean together, right? And how many items total transaction is always 7 in this case, right? From
Mm-hmm.
here you can calculate, right? This one intersection divided by n, that you get the support, right?
Right.
And then to get the confidence, again you calculate the how many times that x is happen. X is here, isn't it?
Yeah. Mm-hmm.
Okay, so you can get that, correct? So then you calculate the confidence. Confidence is what? This one,
This one.
yeah, n of intersection divided by nx, isn't it?
Yeah.
Okay, so then you can calculate now. Support is 29%, confidence is 50%, right? And then check what is the minimum. Minimum is 20 and 60 here. So if above minimum, then yes. If lower than minimum, no. This is 60. The minimum is 60. This is only 50. So it's not included in the rule.
Mm.
The one that above for support and confident both, okay, above that minimum threshold that you set, then become is in the rule. And then I will just collect all the one that is in the rule here into the output. Oh, easy or difficult? Is it clear now or not?
Yeah. More clear now.
Okay. So that's it. That's the idea of the association. Okay. How to compute combination and so on, that's programming, right?
Yeah.
Okay. So all the thing you need to do is to understand the idea first. Okay. In fact, you don't really need to do programming. Right? The program already done by someone else, isn't it? Okay.
Mm-hmm.
So all you need to know is what is inside. Oh, what is the meaning of support? What is the meaning of confidence? What is the input and what is the output? The output are the rules. So of course, based on the rule that easily you can define, right? So if the person buy that items, then you can say, oh, I know what you want to do.
Hmm.
Is it clear?
Yeah.
The idea is very simple but very powerful. Okay. Again, this apply to nominal. Both x and y are nominal. Okay. In regression, remember, in regression, the y, the output, must be numerical. In pattern recognition or supervised learning, the y, the output, will be categorical, nominal. Okay, but the x is up to you. It can be numerical, can be categorical. Correct? Okay, so very important data type. Okay, you need to know the meaning of data type, and then from the data type you can get the analysis that you will use. Okay. Okay. So is there any question?
So far, so good for me, sir.
How about the others? Open your camera, please. I'm not sure whether you are there or not. Okay, so let's go to the next idea. Okay, the next idea is hierarchical clustering. You can check in Google Classroom. We have the slide on that. So, okay. So what is clustering? This is called unsupervised learning. Okay, clustering is also called unsupervised learning. In supervised learning, okay, for example, supervised learning is what? Regression, classification are both supervised learning. You have the input, you have the output as your data, right? You have the input and the output as your data. So that is called supervised learning. In unsupervised learning is basically clustering. What is this? You have only the input, you don't have the output. You ask computer to give you the output, which is the category. Okay, so clustering is called unsupervised learning. It's a technique to group the object, okay, your input, okay, based on the distance or similarity. Okay. If you calculate the distance, my question to you, how do you calculate distance? Can you calculate the distance between strings? Can you calculate distance between if you have two numerical data, you can calculate distance, isn't it?
Yeah. You
Yeah. So let's go to my website so that you can check the distance. Okay. So I give you the chart, the link for the distance. Can you open it?
Yeah.
Okay, so here it is. Right, so this is about similarity. Okay, so I have here different method, okay, to compute distance. So depending on your data type, okay, if your data type are binary, okay, so you can use this matching, simple matching coefficient, Jacob coefficient, Hamming distance. Okay, if you click here, for example, okay, you will get the formula, you will get the example, and you can also get, I have developed the computation, okay, calculator that you can also calculate. So here example, I have 6 dimension, up to 6 dimension. Okay. So you can just put 0 and 1, this is binary. Right? So you can also calculate Jacob coefficient or Jacob distance. Okay, Jacob coefficient is similarity, Jacob distance is the distance. So these are the formula, okay, and this is the calculator that you can calculate. Okay, and this is the example. So your data is apple and banana, okay, and then for example whether they are the shape and the spear, okay, and the sweetness, the sourness, and crunchiness, for example. These are the 4 dimensions that I put for each object. So these are binary variables. So from here you can put into this value, then you can calculate the Jacob coefficient. So for example 0.75 of Jacob distance. Okay, so if your data is actually nominal or categorical, okay, you can also calculate using this other method. Okay, so this other example you can read by yourself. Okay, and then if your data is actually ordinal, there are many different type of distance. Again, each of these have their own calculator inside. So these are the example for a lot of dimension. Okay, and then you can calculate. Now, if your data is actually string or text, you can also calculate the string distance. Okay. So, example here, if you have the string of, what is this? From DNA, right? String 1 and string 2, and then you can calculate. Okay. You know Turnitin, right? Turn it in. So, or you want to check the spam filter, for example. Then you can calculate, you can just put any string here, for example ABC and ABCD. Okay. Then you calculate the string distance. Oh, this is the normal string distance is 0.42. Okay. Of course, if you have exactly the same thing, it will calculate the exact. Okay. So for example, if you are smart and you are idiot, what is the distance? So we can calculate, oh, the distance is actually 0.5. Next, aside from text and nominal, of course, the most important distance is usually quantitative, right? This is the normal distance that you learn. That is called Euclidean distance. Okay, this is the formula. Okay, for example, in Euclidean distance, if you have 0, 3, okay, your coordinate is 0, 3 and 0, 5, or 0, 4. If you have 0, 4 and 0, 5, the distance is 1. But if you have distance of 4 and 0, then the distance is 5, isn't it? This is the usual Pythagoras theorem, right? So, but in here, we can actually increase the number of dimension, okay? Not just 2 dimension, you can go up to 6 dimension here, and so on. Okay, so there are many other distance that you can check by yourself, including angular separation, coefficient, correlation, and so on. And there are also distance between group. Okay, these are called Mahalanobis distance. So Mahalanobis is an Indian name. Okay, if you look at the formula here, what is this formula? Do you remember this formula?
Distance.
Hmm? Do you remember this formula? You don't.
I think we never learn.
Oh, you learned this, right? When did you learn this?
No. I said we never learn Mahalonobis.
No, you check the formula here. You never learn
Oh,
Mahalanobis, but you check the formula here. You learned this 2 weeks ago from me.
right. This is from
When we discussed
uh
discriminant analysis, do you remember? Check again. Discriminant analysis, LDA.
hey. Oh yeah, the name.
Okay. So if you check the discriminant analysis slide, you will see this formula. So basically, discriminant analysis is about Mahalanobis distance. So, okay. So again, I have the calculator here. I have the example in Excel. Okay, and you can download it, and then you can also use using this one, Mahalanobis distance. Okay, so the pool covariance and covariance matrix you can calculate, and then you can calculate the distance also. Okay. Next, so if you have different, normalize first. There are two types of normalization. Okay, there are two types of normalization. It's called mathematical normalization and statistical normalization. So if you read this tutorial, you will see I developed many different mathematical normalization. Then this is the any way of normalization. Okay, I can put this value, for example, I can normalize the index using this formula. Okay, so you can see I created any formula that I can create, and it will become a normalized index. What is the meaning of normalized index? Meaning between 0 and 1. Okay, if you have any value, you can set it into another value which is range between 0 and 1. Okay, so another technique is if you have rank, for example, here. If you have rank, you can calculate using this technique that I put in here. So for example, this is your original rank, which is -2 to +2. Okay, you can convert it to 1 to 5, and then I can normalize the rank using this formula. Okay, so that your ranking now become numerical. Yeah, from ordinal value, for example, preference, 1 to 5, right? Or -2 to +2, right? Then you can put that into quantitative, from ordinal to quantitative. This is the technique. Okay. Next, if you have mixed data type, what will happen if you have mixed data type? For example, you have binary and then combine with string, okay, and then you combine with what ordinal data and nominal data together, right? How are you going to calculate the distance? So these are the example. I give example here. Okay, one is quantitative, the other one is nominal, ordinal, and binary. So and then I can put them together into one table, right? From there, I can transform each data into coordinate. Okay, so you read this tutorial by yourself. Okay, and then for each measurement scale, either nominal or ordinal, interval, and ratio, then you can put them into coordinate, something like this. Okay. After that, once you put into coordinate, then of course you can normalize them. Okay. Why do you need to normalize? Because the unit are not the same, right? So you normalize so that the unit will become the same. Okay. from there, you get the whole things. Yeah? After you get the normalized value, okay, between 0 and 1 for all, then you can simple weighted average distance. Okay. Once you do that, you can check all the others. So up to here, the distance. Any question? Did you get it? Is it too fast? If you don't ask question, I will assume that you know everything.
Clear, sir.
Clear, eh? Distance is clear, yeah?
Yeah, yeah. Yeah,
Okay.
it's in your website also, so I can read.
Okay, good. No, everything I teach in this class is always in my website.
Oh, okay.
Okay, so
Okay.
you can also read everything. What is the distance finish? Okay, let's go to the hierarchical clustering. Okay. So now you have object. The object can be numerical, can be categorical. Remember, huh? And then from there you can calculate distance. Remember, when I talk distance is always between two objects. Each object will have several features. Each feature have their own data type. Then you can combine into distance. If you cannot calculate the distance, then you cannot do clustering. Okay, the distance is the prerequisite of clustering. You got it? So what is clustering? We want to maximize the distance between cluster and we want to minimize the distance within cluster. That's the idea of clustering. Okay? That means you want to find the natural grouping among the objects. So I give you example here. There are two types of clustering. Okay? One is called partitional clustering. The other one is called hierarchical clustering. Okay? So partitional clustering is called k-mean usually. Okay? How many clusters that you want? Okay. So hierarchical clustering, you will put hierarchy. Okay? Something like this in the left side. So if I have the data, okay, I calculate the distance, right? And then finally I will create a kind of hierarchy based on those distance. And then that hierarchy represents set within set. Can you see dendrogram? The hierarchy in the left is called dendrogram. On the right side, drawing here represents set within set. Okay. So the dendrogram or the hierarchy here, okay, have represent, if they are in the same branches, that means they are similar to each other, closer to each other. Is that clear? Oh, let's see this example. Okay. So based on the clustering, we can say that the human is closer to the primate, isn't it? Okay. To the monkeys. And humans and monkeys are closer to mammals. Right? So based on the clustering. These are the application. Right? So now if you create the web directory of everything that you create in, for example, Alta Vista, Yahoo, for example, right? So they get the website, okay, and then they cluster. Okay? You create a kind of hierarchy, isn't it? So, okay, business together, yeah? And then inside business you have finance. So you create a kind of decision tree inside. So if you want to create that, you use hierarchical clustering. In what is the difference between decision tree and hierarchical clustering? In decision tree, you know the output. That is supervised learning. In hierarchical clustering, you don't know the output. You don't know the cluster. The algorithm will create cluster for you. Okay. So How to calculate that? Number one is to calculate the distance. Okay, so these are the example of distance. So distance between Patti and Selma. How do you take the distance? It's up to you how to calculate the distance. One is called edit distance or transformation distance. The idea is how many transformation I need to change from one to another. Okay? For example, the change is dress color I will change, the earring shape I will change, hair part I will change, then 3 points of the change, then the distance is 3. Okay, so the distance between Marga and Selma, okay, you change the dress color, you add earring, okay, decrease the weight, take up smoking and lose weight, then these 5 points. So these are the distance, is called edit distance. How many edit that you need to put from one to another. Okay, so here example of edit distance. Okay, Peter and Pedro, okay, Piotr, Petros, all of these are actually the same root of name, right? So how many edit distance? Okay, the edit distance in this case only use 3 transformation. Yeah? If I substitute, if I insert, and then if I delete. Okay, so how many substitution, insertion, and deletion that I need to go from one string to the next string? That is called edit distance. This is how you calculate the distance between strings. Okay, so from there you can, based on the edit distance between the name only, okay, we can actually create this hierarchical clustering, right? Now, this is amazing part. Once you create the hierarchical clustering, okay, and then you put that into GIS or geography, right? Wow, now you start to see how the language change, okay, by the region, isn't it?
Yeah.
Interesting, right? Once you apply this, okay, this is just first time you just change based on the name only, right? And then you know where it is, right? And then you put it into the map, suddenly you have new knowledge. Amazing, isn't it? You got the idea? Okay, but if you do a hierarchical clustering for the color of this what is this flag, it will not create any meaning because the flag is not really historical, right? They just based on its country, not based on universal method. Okay, so you can do it by yourself. Okay, so now what will happen if, remember this our example of katydid and grasshopper, right? Okay, so then we can calculate the distance and then we cluster them. You see the clustering is now become like this. Oh, you can see there is 2 groups, right? So the length here, I will show you in red. Yeah, this length, the one that very long length, that represent the separation, bigger separation. Okay, of course, each of these are the data. The leaf in here is the data point here. Represent. Clear, yeah? So clearly, you can see that clearly there are 2 separate clustering. Based on hierarchical clustering, you can see the cluster. Is it clear or not? So the same thing. Now, suppose this is how are you going to use clustering for outlier, detecting outlier, right? Suppose there is an outlier here, right? This one. Then you do a hierarchical clustering, right? Then the clustering will become like this. See, this is the outlier. So you can detect outlier using hierarchical clustering. Interesting? Okay. So the technique, how to compute. Okay, the computation. There are many methods. Okay, I can tell categories into two parts. One is bottom up, the other one is top down. Okay, bottom up means you start from the items from each of the object, and then you merge them together until single cluster together. Okay, top down is you start with the whole everything as one, and then you divide until each object. Okay, so so that's the technique. Now, based on that, okay, this is an example. Okay. Based on this object, you can calculate first what is the meaning. You need to calculate the distance matrix. From the distance matrix, then you can combine. Okay, so you can combine, and then you can combine again, and then combine again. Finally, you get the hierarchical clustering. Okay, so now depending on how you compute the distance and how you combine, okay, there are many ways to tell hierarchical clustering, and each of this technique will produce different kind of clustering. Okay, here I can say, for example, single linkage, meaning they just calculate the two nearest neighbor and then they combine together. In the complete linkage, they combine the farthest neighbor and then they combine together. In group average linkage, they combine the average distance between pair of the two objects. Okay, and the word is using the variance. Okay, this is more complicated method. There are many methods aside from this, but these are the main one. Okay, so you will see the result will not become the same. Okay? Not exactly the same, but the idea is almost the same. For if you can see there are really two separate cluster, then anyway using single linkage, average linkage, word linkage, you still see the two cluster, right? But the result is not exactly the same. Okay, so how do you cluster? Start with the object, okay, here, and then you calculate the distance matrix, right? Okay, and then you merge them, that the one that close together, you merge them there. Okay, when you merge them, you create this hierarchy down here. So after that, you can create the hierarchy here, right? After that, what will happen? Again, you merge them together again. The one that close, right? Oh, you create another hierarchy. The one that close, you merge them together, and so on. Do you get the idea or not?
Yeah, I get the idea.
Hmm?
I get the idea.
Okay. So how do you calculate? How do you cluster? It depends on the distance. Okay. If they are close together, you combine. Then you become one cluster, and then combine again, until finally you get one. Everything become one cluster. Okay. Then you create the hierarchy based on how they combine. Okay. So if you go to my website again, there is a example there that you can also check. Okay, so here it is. This is the one that from my website. So this is the practice. Okay, so this is the data that I have. Only two example. Okay, because this is only example, right? Two variables, x1 and x2, and then I have how many? Six objects. Okay, so then because six objects, so I calculate the distance matrix. Right, 0 is not counted, so now I get the minimum of the distance matrix. What is this? Between F and D, isn't it? Yeah? F and D are the minimum, then I combine. See? I combine DF, now become DF. Okay? And then again from the new distance matrix, what I will do, I get again the minimum. Zero not counted. Okay? The minimum that is non-zero. So in this case, 0.71. Right? What is this? A and B. A and B I combine. Okay? A and B I combine. You see the distance matrix here? I already combine A and B, right? And then I calculate again the new distance matrix. Okay? And then what is the minimum that is non-zero? 1. What is this? Between E and DF.
F.
Okay? Then I combine that one. EDF. Okay? Again, I get the minimum, which is 1.41.
41.
Okay? Now I combine, what is this? C and D, F, and E, right? So I combine again C, D, F, E. And then, of course, this is finally you combine all. Okay? A, B, and this become single, right? Then you can plot. How do you plot this? Depending on when do you combine. See, here is 2.5, 141, 1, and then 0.71, and then 0.5, isn't it? That distance that they combine, that is the one that critical. That is the one that you put in here. See? Okay. Then you create, how do you combine them? That is called coordinatic matrix. Okay. The way to combine is the value of you combine, it depends on the value where do you want to, the minimum distance in this case. You get the idea? From here, when you calculate the coordinatic matrix, okay, you can calculate the coefficient relation, correlation coefficient, okay, between the distance and the coordinatic matrix. Then you can get how many percent. So this is like at the R square of the hierarchical clustering. Okay. Of course, the higher nearest one is the best. If negative, so it's not that good. Okay. That's the idea of hierarchical clustering. Any question? Too fast? Okay.
Okay, okay.
Wait. Only one person said okay, the others just sleeping. I don't know. They don't want even to open their video. Anyway, let's go to the partition. Okay, this is another method. Okay, of clustering, which is again unsupervised learning. What's the difference? In a while ago, we do what is called hierarchical clustering, right? Now we do what is called partitional clustering. In here, you determine the parameter K. K is the number of clusters that you want. Okay, K is the number of clusters that you want to get. Okay, so for example, I want to cluster it into 2 parts. Okay? Or I want to cluster it into 3 parts, and so on. So, K means supervised, unsupervised. Okay. Now, the technique. Okay. The technique is rather simple. You move the object to the nearest mean. Okay? You move the object to the nearest mean. I hope my program is working. It's not. unfortunately not working. But anyway, I have it, I think, in my website. Let me find. Tutorial, K-means. K-means. There. So, K-mean tutorial, again. I put in the chat, okay. Okay. So this is partition. So can you see it? So suppose I have four objects, okay, A, B, C, D. And then suppose I have two attributes or features. Okay, variables is only two. In this case, weight and pH. Okay. Okay, let's call it X and Y. So now we want to do a k-means. Okay. Next. So here is to compute. Okay. The algorithm is rather simple. Start with the number of cluster K, and then you can set random. Okay. Each object in each of the object you can set random cluster, and then you calculate the centroid. Okay. You calculate the centroid, and then from there you calculate the distance between the object and the centroid. Okay. And then you group based on the minimum distance. If the object is not moved anymore, that is the clustering. Okay. So here, example. Okay. So these are the example a while ago. So I can see in this case I have two, right? Two cluster. So I will just say this four object will be divided into two cluster. Okay. So what happened? So I will put the cluster is C1 and C2 centroid. So first time the centroid is in this star. Can you see it? Okay. And and then you calculate, huh? You calculate the distance between the centroid and its object. Okay, so this is just Euclidean distance. And then you set the grouping, right? The minimum distance, that is the one that you set as group. Okay, and then you iterate again and again. Okay, this is the iteration 1, iteration 2, and so on. Okay, finally, you will get the result. Yeah, this has been also. This is the program. So, for example, I put in here. So this is the clustering. So you just put the data here, okay, the one that I inputted a while ago, and this is the result. Very simple. So these are the cluster, cluster 0 and cluster 1. Okay. Partitioning. So, again. Okay, so it's an iterative until it's stable. Okay. So here, these are another example. Okay, you set arbitrary, for example, k equal 2. Okay, and then you assign each object to the closest to the centroid. Okay, after that you update the centroid. Okay. Once you update the centroid, then you reassign again and continue the loop until finally it will not move anymore. Okay, so this is example again. So I have this data. Say I set 3 cluster here: K1, K2, K3. Okay, the centroid. Then I divide them into 3, right? And then what will happen? Each of these will move. Okay, the centroid will move, right? So once the centroid move, again you divide them again, and finally the centroid will not move anymore. Okay. Again, this is another example that I put in the website that you can also calculate using this technique. Yeah. Eventually, you will get the result that this is the C1 and the C2. So then you will see each object belong to which group. Okay. So I will try. So this is the example. Can you see this or not? This is my video. I use my program. I created my own. Okay, so I just click any. Okay, I want to create 9 cluster here. So every time I click here, the data will move. The cluster, the cluster will move. Okay. And then it will assign the data based on the color of the cluster. Can you see that or not? Do you get the idea of k-mean clustering?
Yeah, pretty much.
Okay. Finally, you will get something like this. Okay, so something like this. Final result. Okay. So finally, if you click like that, you will get something like this. Now, I can also cluster I use this, for example, for image processing. So in here, I just define 3 cluster there. Can you see? So again, now I can get the different cluster. Okay. So I use the same technique. I use it for clustering of the image. So if I can click 9, then I can click every different color here. This is just clustering based on color. This is the initial value that you put. And there, you get the clustering. Okay, so this is example of application of k-means. Is it okay?
Sir,
Question?
how do you insert that picture, or it's a combination of? No, because actually we have 2 ideas, right? Our group, like the first one that we proposed to you and you said good, and the second one is actually about coffee visualization, sir. So we kind of like basically separate good bean coffee and bad bean coffee, right? Like that. So but we do not know how to like put a picture inside a Python and let the Python do the
Oh, use
thing,
Anu, very easy. I have tutorial on that. Okay, so
Oh,
you go to my
okay.
website. Okay, I will give you tutorial on that is in Python. Okay, here is the chart. Where is the chart? Go here. This is there's an OpenCV there. OpenCV tutorial in my website. Okay.
Learning Python.
Go to OpenCV. OpenCV. Video analysis using OpenCV. That one.
Video analysis.
Okay. The video analysis using OpenCV. You can also use other module like PIL, PIL, processing image. So you can create.
OpenCV is OpenCV is a different software, sir.
No,
Or
it's a module. It's a module like NumPy, like Pandas. Okay?
Okay.
These are the module inside Python that you can just use. It's very excellent.
Yeah, indeed.
Okay, so there is no problem with that. All you need to do is to read, okay, the manual, the help file. Okay, and if you don't know how to use, you just ask in Stack Overflow. Anyway, there are many tutorials of OpenCV anywhere. Also.
Yeah.
Okay. So it just happened my thesis was in image processing, so I created that. Okay, so I hope you get the idea. Oh, my question is this: how about if you have only one dimension? So if you have only one dimension, so basically the k-mean clustering will become a distribution, something like this. Okay. And how do you calculate the error? The error is actually the distance between the object X, okay, and the cluster, the mean of the cluster, which is M. Okay, that's called the SSE, sum square of error in k-mean. Okay. So these are the standard error that you can calculate. So between each object and the in the same cluster. Okay. So then the next question is, how many clusters should I put? Okay. So if you want to know how many clusters, then you check one by one. If k equal 1, if k equal 2, if k equal 3, if k equal 4, finally you will get this objective function. What is this? This is the SSE. Yeah? The SSE compared to the k. Okay? Of course, the larger k will get the lowest SSE, but you want to find the elbow. Okay, so in this case 2, right? So 2 is already enough. You can increase the number of cluster, which make the SSE smaller, but at higher cost, right? Of computation. So in that case, you need to balance between computational cost and the number of clusters. So this is the example. Sometimes not so clear. The elbow is not that clear as in here. Okay. So what else? Yeah, these are the limitation. It's always creating some type of a circle, isn't it? Okay. So example here, okay, if you already know the cluster, so if you want to combine between supervised and unsupervised learning, that is the problem. Okay, this is often happen to many students around the world, not only you. Okay, they are always asking me the same question. Okay, how if I already know that this is blue, this is green, and this is red? Okay, and then I do k-means. What will happen is the k-means will produce something in the right. You see, which is not correct. They said, yes, it's not correct because the algorithm is unsupervised. Okay, if you want to get it supervised, then you do it using decision tree, not using k-means, isn't it? Because the k-means is based on distance. Do you get the meaning? You cannot mix up supervised and unsupervised together because you already know here. And another problem with the k-means is something like this. You see, if you already know blue and red here, and then you do k-means with two clusters, right? What happen is you will get that result in the right hand side. So the result is based on circle, okay? It's not based on the shape. Clear? So then one solution is to cluster as many as possible. Okay? The technique is you cluster first and then you cluster again. Overcoming the k-means limitation like this. You cluster first many and then you put them together. Can you see it? Okay. First you put many cluster, for example 9 cluster, and then you combine together. Then you can get a better result. Okay. Again, the same thing. In here, you cluster many, and then you combine together. Okay, so that's all for k-means, I guess. Is there any question? Partition finish. Oh, very fast. Really no question?
Quite clear.
Quite clear, okay. If no question means you must be very genius.
Huh?
Right? The whole class no question. Wow. Very nice. Okay. Next. I'll discuss next. What's next? Anomaly detection. Finish, close. Anomaly detection. So what is anomaly? Anomaly means outlier. Okay. So there are many objects that sometimes very different from the most other object. Okay. So anomaly not always bad. Okay. Outlier in here, this example, outlier. Okay. This is the red, is outlier, right? So sometimes outlier is bad. Why? Because it's inconsistent with the other data. Right? So, and again, outlier will deviate very much from the observation. So you start to think maybe they are generated from different mechanism. Okay? This is the outlier, right? So if you have several cluster here, there are only 1 or 2 in red here. These are the outlier, right? They are very different from the most other data in the object. So say if you are dealing with stock market, right? Suddenly there is a jump, very big jump, okay? Whether go up or go down, that is outlier. Right? So that means outlier is also important, right? So every day you don't see earthquake, you don't see tsunami, right? Suddenly there is an earthquake or tsunami. So these are outlier, isn't it? Okay. So application of outlier detection is early warning system. Okay. Credit card fraud detection. Okay. Medical analysis for detecting unusual symptoms. Intrusion, network intrusion, for example, or certain ecosystem disturbance like a hurricane, flood, okay, earthquake, a while ago, or searching for best talent, okay, best people in art, best people in sport, and so on. So maybe you can also give any other example of outlier. Okay? So outliers again not always bad. Okay, so in sport, for example, Tiger Woods is the best player in golf. Is an outlier, right? Exceptional people, okay, the genius are exceptional people. It's not always bad. Okay, so outlier have also problem. Okay? So we know that ozone in Antarctica is depleting. Okay, but when they put the satellite to detect that, they did not record what happened. Apparently, the satellite actually have it, but they did not record it because it's too low. Then they discharge it as outlier. So be careful when you have outlier and you did not put that, because usually outlier is discharged, right? So now anomaly detection is basically checking the anomaly, the outlier. Okay, what is that? The data that is different from the normal classes. Okay? There is some extreme variation that is not normal. Okay? There is some big noise or big error in the measurement. Okay? Sometimes it's bad, sometimes it's good. We don't know, okay? Depending on the context, right? So, of course, we know there are more normal observation than abnormal observation. See, outlier is rare. That's why it's called outliers. Okay. So then to detect outlier, okay, one way is to check what is normal first. What is the normal pattern? Then the one that is not normal will be detected as anomalies. Okay. So there are many methods. Okay. I will discuss here graphical method, statistical method, model-based, and distance-based. Okay. So these are the roadmap. So in the graphical method, okay, you can plot them and then you can see the outlier manually. Right? It's subjective based on you. So it's time consuming because it requires human knowledge. Next is to use convex hull. So convex hull means you get the boundary of the data. Okay. Then again from that convex hull method, this is again still graphical. Okay. So using convex hull you can detect the extreme value, but the weakness is how about if the extreme is actually in the middle of the data, not in the outside of the data? Then convex hull also cannot be used. Right. So the most common use of outlier detection is called statistical analysis. Okay. So you assume normal distribution or you assume certain distribution that you know. Okay. So based on that, you have the parameter of the distribution, right? And then you can detect the outlier based on certain confidence limit. Okay. So how to do that? This is the most important step. Okay. Number one, all your data you put into normalized score. In this normalized score, this is statistical normalization, not mathematical. Okay. Meaning, each of your data point you minus with the mean and then you divide by standard deviation. Okay, so you will get what is called z-score. So z-score will have mean of 0 and standard deviation of 1, exactly 1. Okay, and then so you check the absolute value of the z. Okay, if the absolute value of the z is actually larger than c, then they are outlier. Otherwise, they are inside the normal distribution. So what is C? C depending on your error. Okay, so if 5%, you will get 1.96. If 10%, you will get C equal to 1.645. So this is example. So suppose you have this data, right? Then you assume a normal distribution, and then which data are outlier with 5% level of significance. Then you calculate, right? Based on the Z, you can calculate based on this. In Excel, you just put norm this, okay? You know the mean and standard deviation of the data, okay? And from there, you can check the probability, right? So if the probability here is the z-score, the z-score is larger than 1.96, then this is the outlier. So what is that? This one. This data is outlier 80. So you can detect the outlier. Another technique is called box plot. Okay, so box plot does not assume that your data is normal. Okay, so how do you detect outlier based on box plot? Box plot based on IQR. Okay, IQR is interquartile range. Okay, we have Q1, Q2, and Q3. What is Q1, Q2, and Q3? Q1 is the 25 percentile. Okay, Q2 is the median. Q3 is the 75 percentile of the data. Okay, percentile, you just type in Excel, percentile. You get the function of percentile. Huh? Okay, and then you use this formula to get the boundary. So any data that beyond that boundary is considered as outlier. So unlike the previous method with use normal distribution, in here using box plot, you don't assume anything about your distribution. So this is more robust. Okay, so that's what this is called non-parametric technique. Okay, so this is the example, the steps to calculate. Huh? So you calculate I use Excel, so you can check by yourself. Okay. Equal quartile of your data, comma 1, that's first quartile. Quartile data, comma 3, that will become the Q3, okay, 75 percentile. And then IQR is just Q3 minus IQ1. And then you get the lower bound and upper bound. And then from there you check, okay, if the data beyond that lower bound and upper bound, that is called outlier. Is it clear how to detect outlier?
It's clear, sir.
Clear, yeah? So you can practice by yourself. Huh? This is the same data. Okay. So again, we get 80 as the outlier using the same data. Okay. Another technique is to use regression. Okay. So how do you get that? So you plot the trend line and you get the R square. Okay. And then the one that you think as outlier, you remove from the data. And then you plot again. Okay. And you can check. Example here. In the left side, okay, I include the outlier, right? So you see the R square is very low, 0.5. Okay, when I remove the outlier into another data, separated, okay, then you can see the R square is suddenly become very good. So this is model-based outlier detection. Okay. So in principle, in model-based is to sort the combination of data that produce the highest fit, best fit of the model. Okay. So if you want to do this method not manually but using program, then you search. Okay? Meaning I exclude one of that, and then what is the R square? Okay, and then you change you check the difference of the R square. Okay? If they are very significant different, then you know this is outlier. Right? So that means you search for a combination of the data that produce the highest best fit model. Clear, yeah? So another technique is, of course, to use the distance. Okay? So again, we already discussed this. One is using nearest neighbor, and then the other one is using clustering. Okay, so well, here this is an example that we use distance matrix. Okay, so suppose this is your data. Okay, then we can run the distance. Okay, we can run the distance matrix to detect the outlier. Okay, suppose this is your data x and y, and from here I can plot that there are two outlier, right? Now I want to detect automatically, okay, not using my eyes. The computer should detect that. So I calculate the distance. So I get the distance matrix. So this is the formula in Excel. And then this is the formula again in Excel if you want to get the rank of the distance matrix. Okay. And you see here that object number 2 and number 9, okay, is the outlier, are the outlier. Okay? Because the rank is very high. Okay? So the same data, we can set the threshold now, okay, to check which one is the outlier. Okay? So once you set the threshold, then you can say, oh, this is the outlier. Okay? Again, the same thing. Object 2 and object 9 are the outlier that we can detect. You practice later on. You can practice. I give you already the formula even in Excel. Huh? Okay. So earlier the clustering we already discussed using hierarchical clustering. Okay, we can check that this is actually separate. The outlier is here. Okay. Up to here, is there any question? Outlier detection is finished.
Maybe for the first method of outlier detection, sir. I forget the method.
Oh, the first method of outlier detection.
Yeah. So it has some calculation. If it's bigger than certain number, it says that it was outlier, right? If I'm not mistaken, 1.98, 1.98.
Oh, the normal distribution.
Wait, I forgot. Can
Yeah, okay. This one.
slides?
Okay. Yes. This one. Is this the one?
Yeah.
Okay.
On your examples.
In my example is this one.
Yeah. So in example, if there's a data that have the C value -2, is it count as outlier or not? Because
Yeah, you use absolute Z,
oh, okay.
right? You use absolute value of Z, not the Z itself, but the absolute value of the Z must be larger than 1.96.
Oh, okay.
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 So again, I put here is not the Z, but using absolute Z. Okay, I will color it red so that you see this is the absolute Z. Okay, but you know, right? What is this 1.9 and 1.6? You know that, right?
Yeah.
From the standard normal distribution, you already learned statistics anyway.
Yeah.
Yeah. Okay. So what's next? This one you assume normal distribution. If you don't want to assume normal distribution, then you use box plot. Huh? This is the best one.
Yeah, because to be honest, at the beginning I felt that if we use we're not using the absolute C, we just use the C. It's a bit weird, right? Because in the box plot there's the formula was a bit different, right? I mean, like it detects the outlier from the above and the below.
Yeah, look at this way. Yeah? Mean and standard deviation are very sensitive to outlier, isn't it?
Yeah.
Right. So if you use box plot, that is better because interquartile range, which is similar to standard deviation, and median. Yeah? This M in here represents the median. Okay, so the median are very robust against the outlier. So this is actually better method compared to the earlier. Okay, but if you know, okay, if you know that your data, if you plot the distribution of your data is actually normal distribution, don't use box plot. Okay, use normal. The result will be very much different. You will see. Okay, normal distribution is not that stringent. Box plot is very stringent. You know, the range is very big. This one. Okay. This Q1 minus 1.5 times IQR, that is very big, actually. Okay. So, if your data is actually normal, don't use box plot. It's better to use normal. Okay. Good. So, using this, you can detect early warning system. Right? Oh, there will be a disaster. Okay. I don't know what kind of disaster you are thinking. Okay. Oh, there will be some kind of outlier with this code. Okay. So it's useful, right? Okay. Last part that I want to discuss is actually consists of two. Anyway, this is important. So model assessment. So anomaly detection is finished, okay? Or if you have any question, you can ask. The last part I want to discuss is model assessment. Okay, so error is the difference between the true value and the model output. Okay, there are two types of error. It's called fitting error. It's based on the calibration. And there is called prediction error. It is based on validation. Okay, what is this? Calibration means you use the same data that you calibrate during the training. Prediction error is something that out of the data that you use for the training. Okay. Now, overfitting is called unnecessary increase in the model complexity. Okay. When you increase the number of parameter or you increase the number of degree of freedom, basically, you will increase the model variance. Okay. You see, for example, neural network with deep neural network, for example. The number of parameters sometimes is very big. Okay. So that means the variance will become very big. Then it tend to be overfitting. Yeah. The model is very complex. If you just want to solve very simple problem, don't use that. But on the other hand, we have also what is called underfitting, which is the model is too simple that will not fit the data. So we need to balance not to be overfitting or underfitting. Right? The next concept that you need to know is called bias. What is this bias? Bias is an error that cannot be reduced by increasing the sample size. You remember when you practiced WK last time, right? You do repetition, you remember? Right? And then at a certain point, even if you increase the number of repetition 100 times, the error will not decrease, isn't it? So that is the bias, right? Even if you repeat, okay, the sample size increase, but there is a systematic error there, okay? So that is the bias. Clear, yeah? Now, one technique to measure the error is based on variance, okay? So this is additional error to the bias. Remember, the bias is the systematic error that is already underlying there. So there is also variance to additional to the bias that increase because of random fluctuation. Okay, so this is called random error. Okay, this random error you can reduce by increasing the number of sample. Last time you did by repeating your data, right? Or you do resampling last Okay, so then we can calculate the mean square difference, or MSE is the mean square difference between the true value of the parameter P and the estimated P. P caret here is the estimated. So what is this? This is based on the bias, and P in here is the bias, as there represent the variance. Okay, so this is called a trade-off between the bias and the variance. Okay, so there's a dilemma here. Given the MSE, okay, large bias means small variance, and large variance means small bias. So this one you need to use, right? By changing the model parameter, okay, you don't want to be too small variance, you don't want to be small bias, so you need to change it so that the model will not become too complex, which will overfit the data, and will not become too simple, which will underfit the data. So in this case, what you will do is to minimize the MSE. Okay, by minimizing the MSE, MSE in this case is the red color here. See, the bias is the purple color here. You see, the variance will increase by the model complexity. Okay, the bias will reduce with the model complexity. Right. So both are error. Okay, variance and the bias here both are error. When you add together variance plus bias, you get the MSE. Right. So your job is to minimize this as MSE. You got it or not? Okay. The bias is the systematic error, variance is the random error. So you want to minimize the MSE. So finding. Now, in reality, okay, you have the test data, right? So if you look at this, if how much fitting it is, right? It's exactly the same thing. If less fitting, okay, underfitting, okay, that means the model is not good. Okay. If overfitting, the model is not good. So you need to get the balance, which again you minimize the MSE in this case. Okay, so there are there are two possible error. Okay, two possible error for quadrant here. So now, depending on the selected option and the appropriate option, okay, whether it built or not built. So there are two kind of error, what is called error of commission and error of omission. So here it is. Okay, so now depending on the truth of your hypothesis and the test result, which is the prediction that you make. Okay, what is the actual value? The truth is the actual value of the output, right? The Y value. Say for example, this is positive or negative. And then the result of your prediction, okay, either positive or negative, right? If the truth value, okay, and the test result is exactly the same, so there is no error, right? So this is called true positive. If the truth value is negative and the result is, I said, the same negative, then this is true negative. Again, there is no error, right? But if the truth value is positive and the test result is negative, so we call this false negative. So in statistics, we call this alpha, or rejection error, or type 1 error. Okay? If the truth value is negative and the test result is actually positive, right? So this is called false positive, FP. Okay? In statistics, we call this beta. Okay? So sometimes we call this also acceptance error or type 2 error. Okay? So I make a diagram down there with the purple, blue, or orange. The TP is the true positive. TN is the true negative. Okay. FN is the false negative, and then FP is the false positive. You see, yeah? So up is positive, down is negative. I make that diagram here. So now if you check the probability of error between alpha and beta, okay, alpha is the error of omission, which is false negative, and the error of omission of false positive beta, you will see the probability of error is something like this red color. Okay. So if the probability is about straight line, then you know this is the random guessing only. Okay. The one in blue is better judgment, and then the one in red is better judgment with extra information. The ideal case is, of course, zero, right? Zero error of commission or omission. Now, if you calculate based on the distribution, okay, so, and then you move the threshold between this, then you will see this is the location of the Fn, false negative, and Fp, which is the false positive. Okay. So you can move the threshold, okay, so that if you move it, okay, you can get the Fn smaller. From there, you can calculate many measurement of effectiveness, performance indices. One is called sensitivity. The other one is called specificity. Okay? How often we find that we are not looking for. So the formula is just there. Another indices is called FP rate, accuracy. We already see this. Okay, accuracy versus 1 and versus 2. Okay, depending on how do you calculate. Okay, these are the formula that you can just plug in the numbers. Okay, so if you have a document and then you want to check, okay, whether they are relevant document, okay, or not, then you can calculate the relevancy of the document using this value. Okay, and the precision is computed using this formula here. Okay, these are just the formula. And then from there you can calculate the other measure, for example, the FDR, okay, false discovery rate, or F measure. Okay, so these are the formula. Again, everything is just plug in formula, okay, or plug in numbers, then you get into this value. Okay. So check here, okay, the ideal case of precision and recall is this graph. So the ideal case is the other way around. Okay, on the top right is the ideal case. So you can check. Now let's give you example of the confusion matrix here. Okay, in the confusion matrix, the diagonal are the true value. Okay. The one that off diagonal are the error. Okay, from here we can calculate many of these FDR. You can calculate the relevant. All of this you can calculate. Okay, if you have this data of the confusion matrix. So confusion matrix is very important. Okay, to calculate everything else. So another technique to check is called ROC analysis. ROC represent receiver operating characteristic. Okay? So basically what is this? This is the TP rate, okay, the true positive rate compared to the false positive rate. Yeah? Okay? So how do you interpret ROC? There. Okay? ROC is something like this. So if you look at this, okay, all you need to know is where is the random guessing line and where is the ideal model. Okay, so if you look at this classifier A and classifier B, okay, then you can check which one is better. Of course, A is better in this case because A is closer to the ideal model. Do you get the idea or not? Okay.
A bit.
A bit.
Yeah, the last one is clear.
Okay. I give you example. Okay. Last time I do traffic analysis in certain road. Traffic analysis in certain road.
Yeah.
Okay. So I got the data. I scrape the data. Basically, there is a report, police report that every 30 minutes they report in Metro Manila. They report all police. Yeah, actually no police. They are called MMDA, Metro Manila Development Authority. So it's kind of police, but for in here Pamong Praja, police Pamong Praja in here.
Yeah.
Okay, so they report it every 30 minutes and then they put it in the website. Okay, so you can check their website anyway, still there. And then I create a program to scrape that data. Okay, and then I do this kind of data analysis, okay, AI things. And what happened is 60% of the data is always in yellow. They put it into three categories: yellow, green, and red. Red mean congested, yellow mean okay, semi congested, and green is very light. Okay, but 60% of the data is already in yellow, right? And then there is small in red, and there is small in a lot of things in green. So red is actually rare. Okay? Congestion is actually rare. Only happen in the morning and only happen in the evening, right? So what happened? If we do a data mining or machine learning or AI in this case, right? Random guessing line. What is the random guessing line? Without doing anything, okay? Without doing any analysis, I already get the 60% correct. Why? Because the data is already all yellow.
Oh. Yeah. Center.
You got it or not?
Yeah.
Okay. I want to emphasize the random guessing line. Okay. So random guessing is not necessarily bad things. Okay. You can get already 70% correct. Okay. So in that case, if you get only, say you use neural network after that, okay. After you get neural network, you get, what is this? 40% precision. Which is below random guessing line, isn't it? Then that analysis is useless. Because without doing any analysis, okay, I already know, okay, I just close my eyes, I just get the prior probability of each data, red, yellow, and green. I already know 60% or 70% is yellow. So without doing anything, I just guess yellow, I will be 70% or 60% correct, right? Right. So yeah. So then if your analysis using all method that you are trying to do is below that random guessing line, then your analysis is in doom. Right?
Yeah.
Okay. Then these are the technique, okay, of computation that actually already in WK, right? Last time you did not ask, but I'm telling you, WK will give you all these numbers. Then you are asking, oh, what does this number mean? I'm just giving this. The numbers mean the computation based on this formula. That's it. Okay, they propose this formula on that formula to represent some performance of your analysis. Okay, but for me, the most important is the common sense, right? If the common sense say, oh, your result of analysis is actually below the random guessing line, then something wrong with your analysis. Okay, so up to here, I think this is the end of the semester. Please submit your final project in Google Classroom. Okay, and I think between 15 to 18 December, I will put the grade in Google Classroom again, so that you can check.
Any format, sir, for the writing, like
in Excel,
production? Oh, okay. Data code. Okay.
Okay, I will put in Excel. Okay, so that you can check the computation.
Sir, is there anything else that we need to submit?
Yeah, only I think
maybe the paper or our
the paper.
or
please check in Google Classroom.
Uh-huh.
Where is the Google Classroom? Google Classroom.
Analysis data and
artificial intelligence. The last one is final group project, isn't it? So you just your data, if you have it. So in principle, I need to be able to run the same result with you, right? So you give me the input, you give me the output, and then I will run it to test whether what you are doing is correct. And then if you have the code or the program name, you just tell me the setting. If say you use Weka, for example, you just tell me the setting. If you use Python, then you need to tell me the code. Huh?
Okay.
After that, you do a report analysis. If you have paper, you can submit it the same place there. Okay. Okay.
For the requirements for the paper, it's the
paper
same with
optional.
the one before, right?
Yes, the paper is optional. Okay.
Yeah, I mean the format.
The format is ACM. You just download the format. ACM data format. ACM paper format is there. Yeah. Okay.
Sir, for the report, just input, output, and what method we use.
Yeah, and then your analysis, the result, and the interpretation, right?
Okay.
Okay. And what is the business benefit? Oh, for example, okay, you don't just train and then give me the result. Oh, I have 90%. You need to test with the new data set, right? To predict so that you can use for your business, right? Okay. Don't just give me the result of analysis with this how many percent of precision or accuracy, but I want you to test if you can actually predict.
Okay, sir.
Right?
All right.
All right. With the new data that is not in the training data, yeah.
Okay. I have a question, sir. Like, what I have understood from our other lecturer that if our target variable like the y, it's like binary data, right? But if the proportion of or the ratio of the yes and no is not equal, we need to stratify the data. We need to apply it as well here?
Yeah. So if depending on the method that you use, okay. If, for example, in naive Bayes or you use what is called LDA, that prior is already including that, right? The prior probability. The prior probability is representing how many yes and how many no. The probability, right?
What I meant is actually the yes and no is not balanced. So
yeah, not balanced. That's why you put prior distribution there. The prior probability, you put it there. You multiply your posterior with the prior. Do you understand what I mean by prior distribution?
No.
Prior distribution is how many of your yes compared to the total data? How many of your no compared to the total data? That is prior distribution of yes, prior distribution of no.
I think it's 1/5 and 4/5.
And then multiply your result with that prior.
Oh, okay.
Right?
Okay.
Okay. And then what else?
Nothing else.
Nothing else. Good. So if you want, this is not based on the exam is until here, yeah? From the beginning until here, until today. Okay. So if you want, this is not including the exam. You can check in my website. There is a tutorial on Q learning, okay? Reinforcement learning. Okay. I did not include that here yet, but that is important also. Okay, but that's for games, mostly for games. For example, if you want to beat the chess or Go player, last time like Google AlphaGo, for example, right? How they make it, that is based on that reinforcement learning. Okay, so thank you very much for the semester, and I hope you enjoy. And if you like it, you recommend to your junior next time. Okay. Okay. Bye bye.
Thank you,
Bye-bye, sir.
sir.
Thank you, sir.
Thank you, sir.